thanks for clicking on this next Prenarculus production. Today we're going to talk about right triangle trig. We're going to have a review of some things that you did over in shapes class. Okay, let's get started and let's see how this all works. I'm sure there's a very good chance that many of you will remember how we did this. Okay, so a shapes class review. In geometry, you learn the very beginnings of trigonometry, which here in this course, pre-calculus, we are going to expand upon, very much so. When you worked with right triangles. So down here we have a right triangle. There's a right angle at B, okay? And you learned about these three different trigonometric functions: the sine, the cosine, and the tangent, okay? So the way that you learned them, more than likely, was with this simple statement here, which your teacher probably told you was SOHCAHTOA, okay? Where the sine of angle A was the opposite side over the hypotenuse. The cosine of angle A is the adjacent side over the hypotenuse. And the tangent of angle A is the opposite side over the adjacent side. Now, we need to define all three of these sides on the right triangle. So, on the right triangle, the one side that doesn't change is the hypotenuse. The hypotenuse always occurs across from the right angle. So, in this case, side CA is the hypotenuse. Now, since we're talking about or working from angle A, the side opposite angle A is the one across from it, which is over here. That's side CB. And the adjacent side is the side that's attached to the angle, attached to angle A, but it's not the hypotenuse. That's side BA. Okay? Now, you do have to remember that if I change the angle here, so for example, if I were to ask you the sine of angle C, well, from angle C, the one across from angle C is over here. So this is angle BA is angle C's opposite side. And then angle C's adjacent side is this one, CB. So the angle that you want to actually calculate the sine, cosine, or tangent for is important because it leads you to where you start and then where you get the opposite or adjacent side from. The hypotenuse, again, is always across from the right angle. Okay, so let's work on doing some of this. For example, here is a right triangle. There's a right angle at angle C. Okay, all three sides are labeled. Now remember, you could use the Pythagorean theorem to find the three sides if you wanted to, right? Your Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse. So 5 squared plus 12 squared would equal 13 squared. And sure enough, that's true. Okay, so this right triangle works. All right, but what we want to do is we want to find the sine. This is the abbreviation for sine, S-I-N. So the sine is the opposite side divided by the hypotenuse. So from angle B over here, the opposite side is across from it. That's 5. Over the hypotenuse, which is across from the right angle, that's 13. So the ratio for sine of B is 5 over 13. The cosine of A, cosine is the adjacent side over the hypotenuse. Okay, remember? SOHCAHTOA. Whoops. SOHCAHTOA. All right. Adjacent over hypotenuse. So from angle A, the adjacent side is 5. That's the one attached to angle A. That's not the hypotenuse. And the hypotenuse is 13. So cosine of A also happens to be 5 over 13. Okay? And then the tangent of B, tangent is the opposite side over the hypotenuse. Oh, I'm sorry. Opposite over adjacent. Opposite over adjacent. All right, opposite over adjacent. So the opposite side from angle B is 5. The adjacent side to B is 12. So 5 over 12 would be the tangent of B. That's the ratio that represents the tangent of B. It's a ratio, it's a fraction. Okay, all right, that's how we use our definitions. Okay, so let's try to solve a right triangle using trig. We're going to try to find some angle measures or side measures. Okay, so we're going to take the information that's being provided to us, pick out a trig function that we can use, and then see if we can create a ratio and find that value. So, for example, I want to find the side W. Here's side W over here. I have the 10 on this side to work with and the 54 degrees. So let's start with the angle. That's what's most important because we're going to work from there. 54 degrees is my angle. I want to find the side with W. Well, W is the side that's opposite 54. So I have that side. That's what I want to find. And then this side with the 10 is the adjacent side. So the trig function that uses opposite and adjacent is tangent. So I'm going to set this up as the tangent of 54 degrees is equal to W, the opposite side, over 10, the adjacent side. And now I want to solve for W. So I'm going to multiply both sides by 10 to get W alone. I get 10 tangent of 54 degrees is equal to W. Okay. Now I can calculate that in the calculator. So if I come over here, I have my graphing calculator here. What's important to note is that your graphing calculator always starts in radian mode. You can see that up here at the top. It says radians. So to change it, push the mode key. Okay, and then you push the down arrow. We're going to this one that's highlighted with degree, radian. So we're going to go over to degree, and then you're going to push the enter key down here. And then that should highlight degree. If I push the left arrow, you can see now it's highlighted. All right, so now I'm in degree mode. I'm going to push second and the quit button to go back. And I want to calculate 10 tangent of 54 degrees. So I'm literally going to type that. I have 10. Push the tangent key, 54. Okay, I'm calculating in degrees. I'll close the parentheses and press enter. And it gives me 13.7638. So we're going to round to the nearest tenth. So we'll say 13.8. So W is 13.8. That's my answer. Okay. All right, let's go ahead and see if we can find X here in this problem. Again, we're working with this 33-degree angle. We have the 12, and we want to know X. So X is across from the right angle. So X is the hypotenuse. And then this 12 is attached to the angle side, the 33. So that's the adjacent. So adjacent and hypotenuse is cosine. So we're going to do the cosine of 33 degrees is equal to adjacent 12 or hypotenuse X. Okay, now I need to solve this for X. So this is a little more complicated. To solve for X, I cannot have X in the denominator. So I'm going to multiply both sides by X to get X out of the denominator. So I have X times cosine 33 degrees is equal to 12. Now cosine 33 degrees is a number, right? I'm going to type it in the calculator in a minute. So I'm going to divide by it on both sides. So X is really 12 divided by cosine of 33 degrees. Okay, so now let me say that's approximate. So that's approximately, let's come over here. We're going to do 12 cosine 33 degrees. So we have 12 divided by cosine 33 degrees. And if we push enter, we get 14.3. So my answer is approximately 14.3. Whatever measure of this side is. Feet, inches, who knows. Okay? All right. So far, so good. Hopefully this is a review of things that you know. So far we've figured out how to find the side of a triangle using ratios, and we've also done it using algebra. But what if we wanted to find an angle? What if we had an angle missing? We can use trig ratios to do that. Okay, so suppose that angle A is what I wanted to find. We'll call it X, just to call it something. It's an angle. Now, here's angle X. Across from X is the 4, right? It's opposite. And then across from the right angle is the 5. It's the hypotenuse. So if we write down our SOHCAHTOA, opposite and hypotenuse is the sine. So we know the sine of X is equal to 4 over 5, opposite over hypotenuse. But now I want to find X. To find X, if you remember, we have to introduce the inverse trig functions. So we're going to use the inverse trig functions to do this. So that's inverse sine. That's how we would write it. Inverse cosine, inverse tangent. Okay, so we're going to take the inverse sine on both sides of this equation. And now the inverse sine and the sine will knock each other out. It will leave me with X is equal to the inverse sine of 4 over 5. So let's come to our calculator over here. We want to find the inverse sine. So if you look on your calculator, here's the sine key in white. The blue key above it is inverse sine. We're going to push the blue second key, and then the sine button brings up inverse sine of 4 over 5. Close it out. We'll push enter, and we get 53.13 or 53.1. This is 53.1 degrees. And you want to have a degree symbol. Please be careful. Okay, we're soon going to talk about writing things in radian measure. And when you do things in radian measure, 53.1 is a radian measure, but 53.1 degrees with a degree symbol means degrees. And they're two different things. Okay, so I want to make sure you have that degree sign there. All right? So let's try to solve this triangle by finding all the missing sides and the angles. Okay, so there's a bunch of ways you can do this. There's a lot of things that you can do. All right, you can use trig. We're going to have to use some trig. And then there's other ways you can do it because you know things about triangles. You can do that. So there's a bunch of stuff. Okay, so let's start by finding the angle X, just to find something. From angle X, we have this 2 across from it. That's the opposite side. And then the 7 is the adjacent side. Opposite and adjacent is tangent. So we have the tangent of X is equal to 2 over 7. So we're going to take the inverse tan on both sides because we want to find the angle. So that means X is going to be the inverse tan of 2 over 7. So let's go into our calculator over here. We want the inverse tan, that's in blue. Push the second key. Inverse tan, 2 divided by 7. Close it out. Push enter. And we get 15.94, so 15.9 degrees. Okay, now there's a bunch of things that you can do. We can go all over the place now. If you want to find y, you know that this is 90, right? 90 degrees, that's 15.9. Subtracted from 180, you can do that. That works fine. You could say, okay, let me find y by using 7, which is the opposite side, and then 2, which is the adjacent side, and do inverse tan. All right, it doesn't matter, really, as long as you find what y is. So I'm just going to do y is 180 minus 90 minus 15.9, just to do something different. So that's 90 minus 15.9, which is 74.1. Okay, so y is 74.1 degrees. And then I want to find this third side that I don't have. I'm going to label it h for hypotenuse. To do that, you can use one of the answers that you just got for these angles and use SOHCAHTOA, or you just want to find h and you have two sides of this right triangle, you can use the Pythagorean theorem. 2 squared plus 7 squared equals h squared. So that's 4 and 49. So 53 equals h squared. So h is equal to plus or minus square root 53, but the negative makes no sense because we're talking about the side length of a triangle. So h is the square root of 53. So there's your three answers, okay? You could have done this by starting and finding y first. You could have found the hypotenuse first. You just needed to solve the triangle. You needed to find all three things on that triangle, okay? All right, so let's keep going. And then what you learned here, I think in Algebra 2, maybe not in Geometry, was you learned about the reciprocal trig functions. So we already know the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. But now you introduce the reciprocal trig functions, which are the reciprocals of all these. So the reciprocal of sine is cosecant. The cosecant is the hypotenuse over the opposite. Okay? The secant is the reciprocal of cosine, which is the hypotenuse over the adjacent. And then the reciprocal of tangent is cotangent, which is the adjacent over the hypotenuse. Okay? So to do this, really, if you find the sine of the angle and you flip over that ratio, you get the cosecant of that angle. All right? So you have to know who is the reciprocal of whom. All right? Sine and cosecant, cosine and secant, tangent and cotangent. Okay, so let's use triangle ABC to find the cosecant of B. Well, cosecant is the reciprocal of sine. We know the sine of B would be opposite over the hypotenuse. So cosecant will be the hypotenuse over the opposite. So the hypotenuse across from the right angle is 13. The opposite of angle B is 5. So cosecant of B is 13 over 5. Secant of A. Secant is the reciprocal of cosine. The cosine would be the adjacent over the hypotenuse. So the secant will be the hypotenuse over the adjacent. So from A, adjacent is 5. Oh, no, I'm sorry. From A, the hypotenuse is 13, and the adjacent is 5. Again, we get 13 over 5. And then the cotangent is the reciprocal of tan. Tangent would be opposite over adjacent, so cotan would be adjacent over opposite. So from A, adjacent is 5, opposite is 12, 5 over 12. All right, and then finally, well, not finally, almost, find all 6 trig ratios for the given triangle. Let's do it for angle A. Okay, so for angle A, we'll go for the sine of A. The sine of A is opposite over hypotenuse. So from A, opposite over hypotenuse is 5 over square root 29. You do have to rationalize your answers, multiply top and bottom by square root 29, and you get 5 root 29 over 29. Cosine of A will be the adjacent over the hypotenuse, which is 2 over square root 29. So I rationalize, multiply top and bottom by square root 29. I have 2 square root 29 over 29. The tangent of angle A will be the opposite over the adjacent. Opposite is 5, adjacent is 2, 5 over 2. Now, from sine, its reciprocal is cosecant. The cosecant of A is just sine, its reciprocal. But I actually don't want to find the reciprocal of this fraction, because this ratio, because if I do, it puts the radical back in the denominator. If I find the reciprocal of the original one, where the radical was already in the denominator, it flips the radical into the numerator. So I get square root 29 over 5. And that's the answer. Now I don't have to rationalize it because the radical is already up top. The reciprocal of cosine is secant. And again, I don't want to flip this one over. I want to flip the 2 over radical 29 over. It gives me radical 29 over 2. And the cotangent of A is just the reciprocal of tangent, 2 over 5. And that's my answer. And then finally, Suppose I had the secant of E, some angle E, it's equal to 4. I want you to use the information to find the ratio for the other 5 missing trig functions. Okay, so let's draw a triangle. We have a right triangle with an angle E, and the ratio for secant is 4. Well, ratio should be a fraction, so let's stick a 1 underneath it. Secant is the reciprocal of cosine. Cosine is the adjacent over the hypotenuse, which means that secant is the hypotenuse over the adjacent, which means that I now know the hypotenuse of this triangle is 4. The adjacent side to angle E is 1. So this side is 1. I need to find the other 5 trig functions. So I need to find the sine of E, the cosine of E. That should be really easy. The tangent of E, the cosecant of E. Secant of E, I already know, it's 4. And then the cotangent of E, I need to find that. All right, so the secant of E is 4, 4 over 1. That means the cosine of E is 1 over 4. It's reciprocal. I'm already done with that. All right, now, to find the sine of E, its sine is opposite over the hypotenuse. But I don't know the opposite side. But I could find it with the Pythagorean theorem. So 1 squared plus x squared equals 4 squared. So x squared plus 1 equals 16. X squared equals 15. The square root on both sides. Need a plus or minus. Don't forget the plus or minus. It seems irrelevant now, but it actually will become relevant later in the chapter. So it becomes this plus or minus the square root of 15. Throw the negative out because we're talking about just a regular right triangle. So x is the square root of 15. So sine of E is opposite over hypotenuse. Opposite, square root 15 over hypotenuse, 4. That means the cosecant is 4 over square root 15. I can rationalize, multiply top and bottom by square root 15. It gives me 4 square root 15 over 15. And then tangent of E is opposite over adjacent. The opposite side is square root 15. The adjacent side is 1. So that's the square root of 15. If I flip that over, it's 1 over square root 15. Multiply top and bottom by square root 15. And I get the square root of 15 over 15. And those are all my answers for those other 5 ratios. It looks complicated, but that's all it is. Okay? And that's it. And as always, thanks for clicking.